Okay. There are certain disadvantages with decision tree. And the first disadvantage is that it has access parallel splits. Meaning, say there are two variables or features that you have. One is A-list celebrities. A-list celebrities. And next thing is estimated budget. And then you want to come up with an output, whether it's a super hit movie or just a hit movie or a flop movie. In that way, you want the information. So you have three classes. Red is one class, green is one class, and blue is another class, assume, right? These three classes. So what will happen is to split the data, it will only be able to come up with the access parallel splits. So when you want to use A-list celebrities, it will come up with a split like that. And if you use estimated budget, it will come up with a split like that. What does that mean? These values will be misclassified. Okay, these values will be misclassified. Whereas if you look at a few other algorithms, what they do is they come up with a split like this. Okay, and maybe like this. So what will happen? Anything which is below here will be red. Anything above that would be green. Anything which will fall here would be blue. That is how you split. Okay, but when it comes to decision tree, this flexibility is not there. Whereas other algorithms can come up with this kind of a split. Since that flexibility doesn't exist, and since decision tree can do only access parallel splits, I mean, this split is parallel to x-axis. This split here is parallel to y-axis. So you're restricting yourself, you're forcing yourself to do only certain predictions correctly. In the good old days, people started off with ID3 algorithm, iterative dichotomizer 3. Then slowly they moved towards C4.5. Then slowly they have upgraded to C5.0. 5.0 is an algorithm which was developed by Ross Quinlan. And the multi-processing capability, he's selling it. That algorithm is being sold by this guy. You need to purchase a license to be able to use that. And to split, we have used entropy, right? As a thumb rule. Alongside entropy, we also have Gini index. We also have chi-square statistic, and we also have gain ratio. These are the other splitting criteria, which is available alongside entropy. It's not just entropy, you also have Gini index, chi-square statistic, and gain ratio. This is just the old decision tree algorithm name was ID3. Then they named it to C4.5 and they put some additional information. They enhanced the algorithm. Then now the current algorithm is C5.0 from decision. These are different versions. Like you have iPhone 12, 13, 14 coming up on September 7th. Okay. Then how do I avoid overfitting? Overfitting or the regularization technique, I would say regularization techniques, which are used to avoid overfitting or underfitting, are called as pruning techniques. Pruning. The moment you avoid overfitting, you're generalizing your model. You're making your model very generic for the future data. That means even if you have slight changes in your future data, it will work well. That is what is the meaning of generalize. Okay. So one is called as pre-pruning or early stopping. You put certain conditions and you say that please do not grow further. For example, if you say maximum depth equal to 1, do you know what will happen? If you have a root node and if you're splitting it, that's it. It will stop here. It will not split any further. It has reached depth equal to 1. Depth equal to 1 is also called as decision stump. Depth equal to 1 is given a special name called as decision stump. Okay. Next, you also have something called as minimum samples split. So if you have to split it further, in this, say you have 1000 observations. When you split it, maybe you have 500 observations here, another 500 observations here. If you say that minimum split, and you're splitting it further, say here, you have now 200, and here you have 300. Okay. Now, if you say that minimum sample split should be 250, minimum samples for me to split should be 250, meaning minimum I need 250, otherwise I won't split. Would it split here? No, because you have less than 250. Would it split this branch? Yes, because you have more than 250. Then you have minimum samples at the leaf node. Leaf means last node. You can say equal to 3. That means even if you have 3 nodes, it's 3 records, it's going to stop. It won't go by our rule. What was our rule? Continue splitting until all the classes are the same, or you have a single row. It won't continue splitting because you're putting a condition. Stop. If you have 3, stop. That's the condition. Okay. Then you have something else which is called as minimum impurity decrease. What is impurity? Entropy. When you continue to split from here to here, when I split, is that specific entropy? I mean, you can put a condition. Minimum, I want 3% reduction. 3% means 0.0. Minimum, if there is 3% or 10% or 20% reduction, only then continue. Otherwise, stop. So you put here 0.03, but here from this level to this level, entropy reduction is say only 1%. So it will not split. You say that doesn't make sense because its minimum reduction is not available. Okay. Same is the case with minimum impurity split. If you have minimum of 10% impurity or 20% impurity, then split. Okay, so these are the various rules that are available. All these are called as what? Hyperparameters. All these are called as what? Hyperparameters. If I say maximum depth equal to 1, if you are splitting the tree, what is the depth here? Once you split, done, it will stop. Maximum depth equal to 2 means it will do the split twice and then it will stop. One split, second split. Okay. Then we also have something called as post-pruning, right? Post-pruning means let the tree grow completely and then apply your rules on that. It will not stop prematurely. It will continue to grow completely. And then you apply the rule. Minimum, if the error value is less than some number, you stop. Then what will it do? It will go there, go up. Then that's post-pruning. Apply the rule. Yes. You will see that, you know what? Only if somewhere the error rate is so much, right? Less than so much, you have that branch. Otherwise, remove that branch. That's called as grafting or subtree replacement. Grafting or subtree replacement. Okay, so do we have anything else here? No. Now, hope you all understand greediness. Hope you all understand information theory through entropy, etc. So now we should get into the code part. Yeah. A different set. The different set are available. So whichever you feel is part of pre-pruning, it's going to stop your algorithm, so be it. So when you grow your entire tree completely, right, you can also say that minimum impurity decrease or minimum impurity split is something that I want to apply. You can still apply. That would be called as post-pruning. So certain regularization techniques can be both helping you perform pre-pruning as well as post-pruning. Very good. Yep. Here we have decision tree code and decision tree datasets. Okay. There are two use cases here. Both of those we'll discuss. One is for classification, another is for regression. So in this case, output variable will be categorical. What happened? So let me open Anaconda. And come on. I'll launch Spider. Because Spider gives you a lot of options, right? When you load a data set, immediately you can double click on that, open that, see what are the various variables and all that. That's why I prefer this. Very good. Okay.